Hello there, and welcome back for another lesson on measurement. In this video, we are looking at the metric system of measurement, and I realize that some of you may be just watching this particular video. You maybe haven't seen the one on customary measurement, so I am going to go back through that process again. For those of you who have seen the customary measurement one, this may be a little boring to you, so please bear with me. But it is very good practice for knowing how to do conversions. Before you watch this video, you need to have seen the video about the metric prefixes, where we talk about what all of the prefixes mean. But once you've seen that, you are ready to look at this memory piece. You should have already assembled your memory piece if you're doing that part with me. In the instructional video, it shows you how to put that together. So let's look at the units on this one. You may have noticed that the units for time are just the same as they were for customary. So I'm not going to go over that again. Metric units do not have units for time. So the time units you don't have to worry about. But they do have distance, capacity, and mass or weight. The distance units in the metric system are based on the meter. A meter is 39 inches. It's slightly longer than a yard. I tell students to think of approximately the length of your arm, especially if you're very tall. You probably have longer arms. So a meter is approximately a yard. It's about the length of your arm. A meter is equivalent to 1,000 millimeters or 100 centimeters, and it takes 1,000 meters to make a kilometer. The unit of capacity is the liter. And you notice this is what I love about the metric system. Look at these comparisons. They're exactly the same. With the customary system, we had to learn all these different units, and they're not all the same. The metric system is based on units of 10. So you can multiply or divide by 10 to get these conversions. And that's what I love about it. For me, it was much easier than learning the customary system. But your capacity units are based on the liter. And then your weight units are based on the gram. And the weight ones have one extra one here. The metric ton is included, and that is equal to 1,000 kilograms. So I'm going to show you again how to do conversions. We'll work this just like we did the customary one. So if you go to a blank sheet of paper in your notebook, we're going to call this metric measurements conversions, because the math skill is on how to convert from one unit to the next. The memory piece is this piece that fits. Again, you have a pocket for this one. So if you want to go ahead and glue that pocket down. And then your memory piece fits in and out of this pocket as you need it. I wanted it to be mobile so that you could take it out and refer to it. But glue the pocket down. And then here's an example. Remember, I gave you an example in the last problem, and then the steps that go with that. So here's the example. How many grams are in 1.75 kilograms? Okay. So if you watch the customary video, these steps are the same. We're going to do exactly the same process that we did. Step 1, and I tell you what, I'm even going to word them the same because I want to emphasize that. So bear with me just a second. Set up the conversion proportion. I don't even want to change the wording on you because I want you to know it's exactly the same. So set up the conversion proportion. And a conversion proportion looks like this. You have 3 fraction bars with equal signs. So that's what I mean. Set up the framework. Organize this process so that you don't have to even really think about what you're doing. You just have to work the math. Step 2 is to write the word ratio. Okay, so we have this part, and we're going to supply the words. So you go back to your example problem that you're trying to solve. And in this one, we are dealing with grams and kilograms. So those are the 2 words that are going to go in this word ratio. Gram and kilogram. Now with the metric system, very often one of these will be the base unit. It'll be grams, liters, or meters, depending on what kind of problem you're doing. So that is not at all uncommon to have one of those base units in this word thing. Okay, that's step 2. Step 3. You write the reference ratio. And this is what comes from your memory piece. So pull that memory piece out and let's find the appropriate one that we need. So we have, let me copy this. That was the word ratio. So now I want to put in the reference ratio. So I look at my memory piece for grams and kilograms. And that's a weight. And right here it is. Kilogram and grams. You're looking for those words that you just wrote. 1 kilogram is 1,000 grams. 1 kilogram is 1,000 grams. That's called the reference ratio. That comes from your memory piece. So you can see every one of these problems has one of those memory piece information things in there. That's why it's so important to know those. And then step 4, which is the last step, we are going to solve, or let's say set up and solve, a proportion. And anytime you see the word proportion, think of the peanut. That's how you do a proportion, is with that peanut. So copy and paste. I'll do that right here. So now we need to go back to our example. And you see this 1.75? That's that number I'm looking for. And that goes with kilograms. So 1.75 kilograms. Come down here, you want to put 1.75 in the kilogram row. Make sure that you're on the right row there. And then you're back to solving your proportion. So I have you to draw the peanut. And again, the peanut is my term. Your math professors at college are not going to call that a peanut. They will call that a cross product or cross multiplying. But I call it a peanut. And you always multiply peanuts. So we're going to say 1,000 times 1.75. And you can use your calculator, or if you know the tricks about moving decimals, you can do that. The metric system is all about multiplying or dividing by multiples of 10. So either way, however it's easier for you, 175 is 1750. And then the step 2 is to divide by the number that's not in the peanut. So you're going to divide by 1 in this case. 1750 divided by 1 is 1750. So there are 1,750 grams in a 1.75 kilograms. So if you go back to answer this question, you would answer it this way. There are 1,750 grams in 1.75 kilograms. The conversion process is exactly the same. This works converting anything. If you go on a trip to Mexico and you need to convert American dollars into pesos, this process will work. Okay? Anytime you need to convert one thing into another, this process will work for you. These are the things that change. So you have to be very careful about getting the right one of these in on that reference ratio. And then it's just a matter of working the proportion. So let's practice a few of these. I will just make some up. Let's do how many milliliters are in 196 liters. Okay, so we set up the framework. Always make 3 of these. The first one will be for words. So I have milliliters and liters. You can abbreviate if you want to. And I need to get the conversion. I need to get the reference piece. Let me move that one page over so I don't have to flip so far. That's not what I wanted. Sorry. Let's move this one page over. Liters, that's capacity. And we are comparing liters and milliliters. So we want this one. 1 liter, 1,000 milliliters. 1 liter, 1,000 milliliters. And then I get the number that I need, which is the 196. That goes on the liters row. And then it's a matter of doing the math. Draw the peanut. And that will keep you from dividing the wrong way. So 1,000 times 196, that's 196,000. Divided by 1 is going to not change the number at all. So there are 196,000 milliliters in 196 liters. Okay, let's do a word problem. A box weighs 253 kilograms. How many grams is this? The process doesn't change. Just because you have a word problem, you don't vary your process. Find your words. There's kilograms and there's grams. So let's write those down. Kilogram and gram. The next one is the reference ratio. So let's look back over here. We're looking at weight this time, so it's not liters. It is down here in the weight category, kilogram and grams. 1 kilogram, 1,000 grams. 1 kilogram, 1,000 grams. And then you go back and get your number, which is the 253. And I apologize if you hear that sound. I don't think you can, but it is an alarm going off. It's nothing wrong. I just forgot to disable that, so please ignore it if you hear it. 253 goes in the kilograms row. Okay. And then we're going to do our peanut. Now the peanut's going the opposite way this time, and that's okay. That doesn't change anything. So you have 1,000 times 253. That's 253,000. And 253,000 divided by 1, that's not in the peanut, is 253,000. Okay, here's another one. Let's change it up just a hair, but not enough to get a completely new concept. A box weighs 456 grams. How many kilograms is this? Very similar problem to what we just did. Okay, the process is to draw your framework, 3 of them, with equal signs. The first one is for words. So I have grams and kilograms. Gram, kilogram. Get the reference piece. It's still that same one, 1 kilogram, 1,000 grams. That will never change. 1 kilogram is 1,000 grams every time. Get your other number, which is this one right there, and this time it goes with grams. So you want to put that in the grams row. Then you draw your peanut. 1 times 456 is 456. And 456 divided by 1,000. Use the calculator, or if you know how to just manipulate those decimals in your head, that will work too. That's why I love the metric system. It's 0.456 or 456 thousandths of a kilogram. So less than a kilogram. And we absolutely can get decimals there, or fractions. No problem. They're just numbers. Okay, we did a capacity, we did a weight, so let's do a distance. So let's keep doing word problems, application problems. Sam lives 9.632 kilometers from Daisy. How many meters would this be? So let's set up the framework. Start with words. Always start with words. Kilometers and meters. You can put either one of them on top. It doesn't matter. Let's get the reference ratio. And right there it is. Kilometers and meters. 1 kilometer is 1,000 meters. 1 kilometer is 1,000 meters. And then get the number from the problem. And it's right there. And that is in terms of kilometers. So we want to put the 9.632 right there. And let's multiply. 9.632 times 1,000. Again, you can use your calculator or you can just move that decimal 3 places to the right. However you prefer to do it. I'm giving you time to do what? So that's 9632. Then divide that by 1. Is still 9632. So in terms of meters, it's 9,632 meters. Okay, one more. A medicine bottle weighs 13.6 grams. The bottle weighs 1.6 grams. How many 1 milligram tablets does it contain? And I hope this works. I'm just making it up. So let's think about what this is saying to me. Before I even start setting it up, let's think about it. Here's this bottle. Let me just draw a box. So here's a medicine bottle. And in the medicine bottle, there are some tablets. And they're identical tablets. So let me make sure I get them to be identical. Guys, I am a firm believer in the power of pictures. And they're not square tablets. Well, they could be, I guess. But let me try again. Okay. So inside this medicine bottle, there are these tablets. And we're supposed to figure out how many of these tablets are in there, given the information that we have been given. So, the bottle itself, the plastic that it's made of, weighs 1.6 grams. The entire thing weighs 13.6 grams. So I'm going to take the 13.6 and I'm going to take away the weight of the bottle. This is the whole thing. And this is the bottle itself. So if the bottle were just empty, it would weigh 1.6 grams. So let's subtract and we get 12.0 grams of medicine. But most prescriptions are in terms of milligrams. They're not measured in grams. I have one that is measured in grams. But most of them are in smaller amounts. They're in milligrams. So what we are trying to figure out is how many tablets are in this amount. Okay. So here we go. We're ready to set up the framework. And let's get the words. We have grams and we have milligrams. So we're going to write those down as the word ratio. Grams and milligrams. And then I need the reference ratio. So I'll look back over here. I don't want distance. I don't want liters. There it is. A kilogram is 1,000 grams. Well, that's not what I'm looking for. I'm looking at grams to milligrams. So this time we have 1 gram is 1,000 milligrams. So 1 gram is 1,000 of those. And we have, where's your other number? Be careful. It's down here. This is the other number that I'm looking for right here. Because we don't want to count the weight of the bottle. We want to count the weight of the medicine. And it is 12 grams. Or you can put 12.0 if you want to. That's fine. Won't change a thing. So then I do the math. I'm going to say 12 times 1,000 is 12,000. And you can tell I made this problem up. 12,000 divided by 1 is 12,000. So that means that there are 12,000 tablets in this bottle. And I know that is not reasonable. That's why I don't need to be making up problems. But it's correct. It's the math is fine. The 12 grams of medicine equal 12,000 tablets in the bottle. Maybe this is a bottle at the pharmacy before they've dispensed the medicine. Sometimes those word problems have that extra step. So you have to read it. I recommend drawing it, whatever you have to do to help you understand what's happening in the problem. In the tape practice, we're going to be doing a lot of word problems. So you'll get plenty more practice, but I wanted to give you some before we tackle that one. If you want to try it yourself and then check it with me, that's always a good option too. But I will see you soon, and I hope you have a really good day. Bye-bye.